Okay, so now we are doing part 3. So part 3 it says that in a particular circuit, so now we are looking at specific circuit, R is 4, L is 3, and C is 0.75. So the three constant values are given. We are to find the maximum value of I, okay, in terms of A, and also to show that this value is a maximum. So to find maximum value of I, you know that you need to set the I dt is 0, right? So from there we do. Okay, so how do we start this question? Now take note that before you even use some of you all may say you can use part 3 because part 3 you already have the I dt, so and so forth. Okay, but before you even use part 2, but before you even use part 2, take note that you need to verify that this value satisfy this equation before you can use the working in part 2, all right? Because only when it's satisfied, then this will be a solution of the DE. Then everything will tie in nicely. Okay, so because this is an A-level question actually, so in the examiner's report, it was stated that a lot of candidates did not verify that these three values actually satisfy this equation. So they lose marks because of that. Okay, so we're going to start the question with first doing the verification. So we first need to verify that the three constant values satisfy the conditions part 2. So we do that by just substituting R equals to 4 and L equals to 3 into the right hand side of C equals to 4L over R squared. So after substituting, I realized that is equals to 0.75, which is the value of the left hand side, which is C. So therefore, we can say that the solution I equals to ATE minus R over 2LT could be used, or any differentiation of that could be used. Okay. So now remember we need to find the maximum I. So to do that, we need to set the I dt is equals to 0. Before we do that, let's write down what is the I dt. You don't have to redifferentiate again because we can use part 2 working. So from part 2, you have already found what is the I dt, which is this. So I'm going to copy this part of the working over here. All right. And I'm going to substitute R equals to 4 and L equals to 3. So that's how I get this expression. And I'm also going to replace my I, all right, in the di dt, this I to be ATE minus RT over 2L. Also at the same time substituting the value of R and T as the given value. So that's how I get this step here. Okay. So let me write down. So to get this step, I substitute R is 4, L is 3. All right. As well as I. Okay. So for stationary value of I, all right, because maximum point is actually a stationary point. So when we set the I dt equals to 0, we're actually finding the stationary value first before we need to verify that that is the maximum point. Okay, so we'll set the I dt equals to 0, so which means that this thing equals to 0. Okay, so let's factor out common factor. So we have a common factor A, E minus 4 over 6t. That's the common factor. And this is 1. This will be 4 over 6t. Right? So I take out this common factor from both terms. Okay. So since A is a positive constant, and we know this exponential term is also greater than 0. So therefore, this term is positive. So it left us to deduce that therefore only this is 0. So which means that t is 3 over 2. So in other words, when t is 3 over 2, we will be able to get the stationary value of I, okay? But we need to verify that when t is 3 over 2, the stationary value is actually the maximum value of I, all right? So we need to do that. Okay, so now we can actually find the value of I first. Substitute t equals to 3 over 2 into the expression for I, so which is at, so t is 3 over 2. E minus 4 times 3 over 2 over 2 times 3. Right, so I substitute t to be 3 over 2, my r to be 4, L to be 3 into I. So that's what we get. So let's simplify this. All right. So this is the stationary value of I, and this happens when t is 3 over 2. So the last part we're going to do, we're going to verify that this stationary value of I is indeed the maximum value of I. So how do we do that? We will use the second derivative test. So to use the second derivative test, we need to get the second derivative. Again, you don't need to differentiate your first derivative again. You can actually pull out the working from part 2. So from part 2, we already have found the second derivative, which is our equation 2. So this part here, we just need to pull this out and substitute r to be 4 and L to be 3. So we get this, okay? We get this. After that, we can further simplify by taking out the common term, which is minus 4 over 6. So this is our second derivative when r is 4, L is 3, okay? So what we do is we need to verify that this is less than 0 when t is 3 over 2. So that gives us the maximum point, okay? So the last part we're going to do is we're going to substitute t is 3 over 2. Or rather, I said when t is 3 over 2. All right. Second derivative is this. And when t is 3 over 2, it is at the stationary point. So we also substitute the I dt is 0. So this will be 0. Okay. So you see that this value here is negative. Since a is positive, and of course this is overall is positive. So therefore, we say that I is maximum when t is 3 over 2. And the maximum I is this value that we have found for I. Okay, so this is the verification part. Make sure you don't miss it out. Right, that's all.